top right of your notes. 8, 28, 13. Help you keep them in order when we turn them in at the end of the semester. 1.3. Our AGS book. Called solutions by adding and subtracting. Okay. Let's realize that this, everything we're doing, of course, is review. But what we're talking about is the old rule. You have to always keep an equation what? Balanced. Okay? Another rule. Whatever you do to one side, you must do the exact same thing to the other side. Of the equation. You guys know what denotes one side of the equation from the other? With this picture, do you know what denotes one side of the equation from the other side? The what? Things on this side, things on that side. What do you think separates one side from the other in the picture that I've drawn?
Equal sign.
The equal sign. You can't add things from over here to over here. All you can do is decide to add or subtract something from this side. As a result, to keep it balanced, what must you do? The exact same thing to the what? Other side. Okay? Divide everything on the left side, you need to what? Divide everything on the right side. Okay? It's that simple. So when we solve, and this kind of gets lost. Too many people, when they learn how to solve equations, just think, oh yeah, subtract the other side to solve that there. We need to understand what we're doing, why we're doing it. When I have an equation, 3x plus 4 is equal to 12.
You subtract 4 to 12.
Basically, eventually, to solve this, to solve an equation, to solve the equation, you're going to make it look like x equals 2, and then there'll be something over here. So basically, you want a 1 in front of the x, and you want it by itself on the left side. So the first thing we do, get the x's by themselves. X terms by themselves on one side of the equation. So what's on the left side that I don't need to be there?
4.
See, a lot of people just think to solve this, they think of more than minus 4 over here, but really the whole reason you're doing that, you're adding a negative 4 here because you want that to go to 0, because 3x plus 0 is just a plain what? You're manipulating an equation. Whatever I do to one side, I have to do what? The exact same thing to the other. So I'm left with 8 over here, am I not? Would everyone agree with that?
Yeah.
To solve for x, I want to know what one of these x's are equal to, not what 3 of the x's are equal to. How do I make any number into 1? Does anybody know? How do I make a 5 into 1? I can divide by 5, or I can subtract by 4. Subtracting by 4 will just make this look more complicated, but if I divide the left side by 3, 3 divided by 3 is 1, correct? allows me to do that is that whatever I do to one side, I have to do what? Exact same. I divided everything on the left side by 3, so I have to divide everything on the what? Right side by 3. We'll get, that didn't come out even. That's okay. That doesn't mean you're wrong. If you haven't got a calculator that does fractions yet, there's a free app on the iOS and the store that will do them for you. We'll divide fractions for you. A fraction calculator. I'm sure there's a better one you pay $2 or $3 for. But you leave it as a reduced improper fraction or a mixed number, and there's your answer. 8/3. Now, how am I going to check my work for this section? Here's what you will do. They ask you to check. You do this problem. Then I want you to do the check. I want to see all the steps and work. You simply plug what you got back into your original equation, except plug, in this case, what? 8/3 back in for x. What you do is you now simplify each side. Simplify here and simplify here. What happens to your 3's there? They reduce before you multiply. Or if you want to multiply, you can see you get 24/3, which is 8 plus 4 is equal to 12. I want to see you multiply that out and write 8 plus 4 is equal to 12. Then 12 is equal to 12. Is this a true statement? I want you to write true underneath there if it's true. If it's false, you write false, and you go back and realize you did it wrong. Check. You're done. If you come up with a solution to something that creates a true statement in an equation, solutions create true statements. Non-solutions create false statements. This creates a true statement. 12 is equal to 12. If I had gotten 10 here, is 10 equal to 12? Would that be a false statement? Say, hey guys, guess what? 10 is equal to 12. Would you tell me I was wrong? You would, wouldn't you? I hope you would. Or I've got a great deal for you. I got $10, you give me 12, we'll call it even. Right? Okay? That is a true statement. If it's a false statement, you did something wrong, or you did something wrong here. Now, because I'm only assigning you 20 problems, I want to see both the check done exactly and the solving done exactly the way I did it. We're going to do like 20 problems today, 16 problems tomorrow, the same type of thing, and then you'll be able to work on them and get them graded correct and turned in on Friday. That's plenty of time, okay? Now, one thing here. What about when you have a problem like this? A problem and they ask you to solve. Is this going to scare you? Hopefully not. It's no different than if there was a 4 there. There's my variable term I'm solving for. I need to get it by itself. What needs to not be there on the left side of that equation? Anybody? Wake up. Okay. If the x was not there, would I have an x by itself on the left side? No, that doesn't look right. If that wasn't there, would that look like more what I want it to look like? So whatever I covered up is what needs to not be there now. So what do I add to a 1/4 to make it into a 0? I add a what? The opposite, a negative 1/4. What do I get as an answer there? 0. What allows me to do that though? If I add a negative 1/4 to the left side, I need to add a what? So I'm looking x over here equal to, well, let's say you can't do that in your head. Well, you have a calculator. If you don't, it's your own fault. 10 minus 1 ABC 4 equals I said to leave them as an improper fraction, so press second function there, because you need to do that because it's much easier to put back when you check. 39/4. Now, your check. I put 39/4 back in. 39/4 I put back in for x, plus 1/4 is equal to 10. So it's 39/4 plus 1 ABC4 equals 10/10. Is 10 equal to 10? Is that a true statement? So it's checked. You're done with that problem. Can we handle that? You should really, in essence, probably get done with this today. We may have to start something new and just make it due the next week on Friday. We'll see.